Hello 8th graders, your video is for section 5.4, which is covering systems in the real world. And so there are three methods that we've learned to solve this system of equations. And so I've created a little graph here which shows you when is the best choice to use each one. And so the graphing method, when you want to have a visual display, when you want to actually see it, like visually in front of you, you could graph it, or when you want to estimate a solution, you could graph it and then estimate it using the XY graph, the coordinate plane. Substitution method, when one equation is solved for one of the other variables already, so when it says like y equals 3x plus 2, then substitution works pretty good. Or if it's really easy to solve for one of the variables, it works well too. If you want to use the elimination method, when the coefficients of one variable are the same or opposites. So what does that really mean? The coefficient is the number in front of the x or y. So like 3x, the coefficient would be 3. And so if you had 3x in both systems, both equations of the system, it'd be easy to eliminate the x's then and continue on that way. And so I have one problem here that we're going to go through, but I'm going to solve it three different ways. The first one I'm going to do is the elimination method. Let's go ahead and look at the question first. So it says, Alyssa has a collection of 35 character figures. So like Star Wars figures or something like that. Some of the figures cost $10 each, and others cost $25 each. The total value of her figures is $575. Write and solve a system of equations to find how many $10 figures and how many $25 figures she has. Okay, so before, and I already told you I'm going to use the elimination method first, but I have to first of all figure out how can I write those two equations. Okay, so the first one, I know that I have 35 figures total, right? And so x plus y is going to equal 35. Then the other one I have to deal with the money. So I have $10, right? 10 times x plus 25 times y equals $575. Now I'm not going to include the dollar signs because it's just going to make it messy. I just get rid of them. So you can see over on the right here, I already have it written what I'm going to do. I'm going to take it times 10 so that I can eliminate the x's. Okay, so I'm going to take this equation right here times 10 so that I can then eliminate the x's. And so if I do that, I keep my 10x plus 25y equals 575 that I had right here. I'm going to take this whole thing times 10, the whole thing. So 10x, 10y, and 35 times 10 is 350. And I'm going to subtract them all, right? So I'm going to change them all to negatives so that I can subtract. And so when I do that, 10 minus 10 is 0. 25 minus 10 is 15. 575 minus 350 is 225. Okay, so now I've gotten rid of the x. So now my next step is to solve for the y. So I go ahead and finish it. So 15y equals 225. I go ahead and divide both sides by 15. 225 divided by 15 is 15. Okay, here's my answer. So I'm going to plug this answer in to my equation to solve for x. So x plus 15, because it was y right here, right? But I'm going to substitute 15 in because I just found that that was the answer, equals 35. Then it's just a one-stepper. Minus 15 minus 15, x is 20. So your solution is 20, 15. When I plug a 20 in for x, I get a 15 out for y. And if you don't, if you didn't want to use this one to begin with, you could plug it in here and it would still work, right? If I plugged 15 in right here, I would still end up with 20 for my answer for x. So substitution method. I'm going to do the same exact problem, but I'm going to use the substitution method this time. So I still have my same two equations, x plus y equals 35 right here, and 10x plus 25y equals 575. And you can see right here I gave you a hint. You're going to solve for y. So you need to get rid of the x. All I need to do is subtract x and move it over there. And there I'm showing you how I'm doing it, right? I'm minusing x. So y equals 35 minus x. Once you have solved one of them for y, you can go ahead and plug this 35 minus x in for y in the other equation. So here I've done that. So 10x plus 25 times 35 minus x, because that's what I said y equals 575. Then I go ahead and do the distributive property. So 10x plus 25 times 35 is 875. 25 times x is 25x, and it said minus, so it's minus. Now I just go ahead and combine what I can. So 10x minus 25x is a negative 15x, plus 875 equals 575. Now I just go ahead and solve the equation. Get rid of the 875 from both sides. So I'm subtracting it from both sides. That leaves me with a negative 15x equals negative 300. And then to get rid of the negative 15, it says negative 15 times x, so I do the opposite. So I divide both sides by negative 15. So a negative 300 divided by a negative 15 is 20. Okay, that should sound familiar because that's just what I found on that other one. But this time I solved for x, right? So now I need to go ahead and do what this says. Substitute x into either equation to solve for y. So I went ahead and put it in the first one just because that's the easiest one to do. I plugged a 20 in where this x is. So 20 plus y equals 35. Subtract your 20, subtract your 20. Your y is 15. So your solution is 2015. Isn't that amazing how I got the same answer that I did up here? I should, right? No matter which method I choose to solve it, I should still come up with the same answer. So my solution is still 2015. So I still need to do the graphing method. And so to graph it, I didn't solve it for y. I could have, but in some cases it might make it a little messier. And so I just went ahead and plugged numbers in for x and y right here, because there were numbers that went in there nice. If I said x is 0, what does y have to be? 35. If I said x is 35, y has to be 0. If I say x is 10, y has to be 25. That's where I'm getting these. If I say x is 15, then y is 20. So I came up with 4 points for that one, and then I need points for the other one as well. And I just found numbers that went in there and that it worked for. So 20 times 10 is 200, and then 25 times 15 is 375. So if I plug a 20 in here and a 15 in here, it equals. If I plugged a 40 in here and a 7 in here, it equals 35 for x, 9 for y, 30 for x, 11 for y. Inputs and outputs. Once I have my points, I can go ahead and graph them. Right? So the red dots are this one, the x plus y equals 25, and the blue dots are this one. So I went ahead and graphed those points, okay? And I can move this up so you can see those a little bit. So 0, 35, 0, 35 is right there, 35, 0 is over here, right? And for the blue ones, 20, I went by 5s. So 20, 15 is here, and then I just need to connect my dots. And so if I take this and go through the red ones, it just seems to go through right there. And if I try to go through my blue ones, you can see that it comes out pretty nicely. And so pretty much what that's showing you is it crosses right there. Well, which point is that? 5, 10, 15, 20, 5, 10, 15. Oh, they cross at 2015. Isn't that nice? Plug that solution in to see if it works, which is what I did right here. I did it twice. I did it once for each equation. So x plus y equals 35. So I plugged it in. Is 20 plus 15 35? Yep. Then I plugged it in here. Is 10 times 20, which is 200, plus 25 times 15, which is 375. Is that 575? Yes. So no matter which way I did that system of equations, I came up with the same answer, that x is 20, y is 15. So I did the graphing method, I did this substitution method, I did the elimination method. And keep in mind, am I ever going to have you do it all 3 ways for one system? No. I'm going to have you choose which system you think you can do the best. So on this section, I'm not necessarily going to say, oh, you have to solve it this way. I'm going to let you have a choice, and you can just solve it whichever way works best for you. So bring that knowledge with you, and I will see you tomorrow. Have a good night.